All right. Good morning. Welcome to Unit 1, Lesson 1, the guided notes for what is chemistry. We talked a little bit about this in the do now, but chemistry is the study and composition, structure, properties of matter, the processes that matter undergoes, and the energy changes that accompany this process. But to be more simple, chemistry is the study of matter and the changes that it undergoes. And we're going to talk more about those classifications, and we'll talk more about the changes in later in this unit. So what is matter? Matter is anything that has mass and takes up space. That includes air, folks. Air has mass. Mass is how much matter an object contains, usually in grams or kilograms. It's very similar to weight. So your weight can be measured in grams or kilograms. But weight is not the same as mass because it depends on the pull of gravity. So weight is actually a force. If you were to go to the moon, you would weigh a lot less. Now, volume is the amount of space an object takes up. So basically, what amount of air you displace on Earth. Some examples of matter are our orange juice, our breath, our cells, our books and our paper and our trees, our dogs and our silly hot dog costumes, and the planet Earth. Depends on what you're describing in these pictures, but energy is not the same as matter. So if we look at light, sound, or heat, this is energy, not matter. We can take a brief look at this, but we're really interested in matter to study chemistry. Matter, the smallest matter that we define in chemistry is the atom. The atom is the smallest unit of an element that maintains its properties. So an atom of copper will always be an atom of copper. You may have heard that you have atoms in you that probably made up the dinosaurs because these atoms of elements never go away. They just get recycled and reused, and sometimes they change into different elements, which we'll talk about in a couple units. In chemistry, we're interested in this very microscopic view. So if we take a tree, for example, we can see the leaves, we can see the bark, we can see a lot of information with our eyes. Even if we take a close-up of the look, we're not down to that microscopic view yet. Here's our microscopic view, but remember, everything you see, those green little chlorophylls taken with the electron microscope, these are probably somewhere in this cell membrane level here in terms of scale. We're talking really small when we're talking an atom. You can see our hydrogen atom is about 500 times smaller than a cell membrane, which is made up of atoms. When we talk about matter, we can break it down into its parts. Matter is either a pure substance or a mixture. A pure substance, we're talking elements and compounds. A substance is defined by a definite composition, a chemical composition, which means that it has definite ways that it acts and definite ways that it looks for itself. If we look at that picture here, tin is always going to look kind of like the silver metal when it's isolated from everything else. Sulfur is usually a yellowish rock. And diamond is just carbon in a crystalline shape. Examples of compounds here or molecules, these are chemically combined. It's sugar, water, and baking soda. And then our crystals, they have a definite composition, but these are usually a metal and a non-metal. We'll talk more about them in the future. So substances, pure substances, can be defined as elements or compounds. An element is one element on the periodic table. So copper atoms, that copper wire is only made of copper atoms. Compounds have a definite composition, so they're the same throughout. Carbon dioxide is the example of we have right here of a compound, also called a molecule here. A little more information on elements. Elements are pure substances that contain only one kind of atom. So you have to find it on the periodic table, like our silver or our mercury here. When we look at our periodic table, these are pictures of elements or who discovered them. These guys are not made of these elements here, but you can see silver, element 47, and mercury, element 80. There's some special elements that are called diatomic elements because they want to be attached to something so badly that they are found in nature attached to themselves. Um, they are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So we will have to memorize these by the time we get to chemical reactions, which is why I'm showing you them now. They make the 7 over here on fluorine plus hydrogen, and hydrogen is a special little creature. Or you can remember our acronym here, our mnemonic device, have no fear of ice cold beer, or come up with one of your own that uses hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Compounds. Compounds are 2 or more different elements joined by chemical bonds. H2O, CO2, those are examples of compounds because they are chemically bonded to each other. Any sample of water anywhere in the world, anywhere in the universe is always going to have 2 hydrogens and 1 oxygen that are chemically bonded to each other. So what's the major difference between elements and compounds? Well, compounds we can break down. It's not the easiest thing, but it needs to be chemical reactions. So we can make water into just hydrogen atoms and just copper atoms. Elements cannot be broken down any further without losing their identity. Now that's not all. Substances can also be mixtures. And mixtures are 2 or more substances physically blended together. So they're sharing the same space, but the properties of each substances are not affected by the mixing. Think salt water. The substances that make up the mixture are not chemically combined. They're just sharing the same space. We can break down mixtures even further into homogeneous mixtures and heterogeneous mixtures. You might recognize those Latin roots. So heterogeneous means different. You can see the different parts. They're unevenly mixed. You can pick out different parts of your mixture. Some examples are salad, Lucky Charms, chocolate chip cookies, oil and water. Homogeneous mixtures are the same throughout. They're evenly mixed and distributed. All parts are going to have the same makeup no matter where you pick the parts. Liquid and gas are usually called solutions because they have some flow. So the atoms flow together in a nice even mixture. Solid solutions are called alloys. So if you've ever seen someone making a sword, they're hitting it together because they want an even mixture to get the properties of both metals they're mixing. Some examples are our stainless steel rods, our honey here, which has lots of vitamins and minerals, and some sugar water. Simple difference between mixtures and compounds. Compounds are chemically combined, which means they need a chemical reaction in order to break them down. Mixtures are physically combined, which means that they can usually undergo physical processes, which we'll talk more about in our next lesson to separate them again. Quick review. So matter can be a pure substance or a mixture. Pure substances can be broken down into elements or compounds. An element is one type of atom, including those diatomic elements. A compound is 2 or more elements in a definite composition. So this might be CO2 or H2O. Mixtures are physically sharing the same space. You can have a homogeneous mixture where it's pretty much the same throughout. You can't pick the parts, or a heterogeneous mixture where you see 2 different parts and they're just sharing the same space. Alrighty, hope you got your notes, and we'll see you on the flip side.